All right, so today we're basically putting a planet on trial. The suspect is a world called Kepler-62f, and it just might be one of the most promising candidates for life we have ever found. The charge? Well, the charge is being a habitable water world. Let's dive into the evidence. And this really is the million-dollar question, isn't it? I mean, we've all dreamed of finding planets completely covered in oceans, straight out of science fiction. Kepler-62f could be the real deal. But is it a watery paradise, or is it just a frozen, lifeless wasteland? That's what we're here to figure out.
So, let's get the basic facts on the table. First off, this isn't our next-door neighbor. We're talking 1,200 light-years away. It's what we call a super-Earth, about 40% larger than our own planet. And based on what we can tell, the models suggest it could be absolutely drenched in a single global ocean. The stakes here are just incredible.
Now, to really understand this planet, you have to go back to how it was found. It all started with NASA's Kepler Space Telescope. Its mission was simple but brilliant. Just stare at one patch of sky for years and watch for the tiniest dips in starlight. Those dips mean a planet is passing in front of its star, and that's exactly how it found the entire Kepler-62 system. And here's the key part. Kepler wasn't just looking for any old planets. It was hunting for planets in a very specific place, what we call the habitable zone. You've probably heard it called the Goldilocks zone, right? It's that perfect little sweet spot where a planet isn't too hot and it isn't too cold. It's just right for liquid water to exist on the surface.
And boy, did Kepler deliver. It found this, a full-blown solar system with 5 planets. You can see the inner ones here, B, C, and D. They are whipping around their star, with years that last just a few days or weeks. They're way too hot. But then you get to the 2 outer planets.
And this is where the story gets really exciting. Not 1, but 2 planets in the Kepler-62 system are orbiting inside that precious habitable zone. We're talking about Kepler-62e and our main target, 62f. Finding a system with multiple chances for a life-bearing world, that was a huge discovery. Now, while Kepler-62e is interesting, it's on the hotter inner edge of that zone. A little too close to the fire for comfort, you know? Our prime suspect, Kepler-62f, is the outermost planet in the system, and its stats make it one of the most compelling worlds we've ever found. So, let's open the case file. First up, its size. This is a critical piece of evidence. At about 1.4 times the radius of Earth, it falls squarely in the super-Earth category. And that's so important because if it were much bigger, it would likely be a mini Neptune, a gassy world with no solid surface. This size strongly suggests Kepler-62f is a rocky world, just like Earth. Next, its orbit. A year on Kepler-62f lasts about 267 days. Now, you might hear that its orbital distance is similar to Venus in our own solar system and think, wait a second, isn't Venus an absolute furnace? And you'd be right to ask. But that brings us to maybe the most important character in this whole story, its star. See, Kepler-62f orbits a K-type star, an orange dwarf, and that is a huge plus. These stars are cooler, they live much longer, and they are way more stable than a star like our Sun. They don't blast their planets with violent flares like smaller red dwarfs do, which makes them pretty much the perfect hosts for life to develop over billions and billions of years. Okay, so let's recap. We have a rocky planet in the habitable zone, orbiting a super-stable, long-lived star. Sounds perfect. Case closed, right? Well, not so fast. There is one major problem we have to deal with. Because it's on the outer edge of that habitable zone, it faces a serious climate puzzle. And here it is. This is the heart of the problem. This planet is pretty dim. It only gets about 41% of the sunlight that Earth gets. To put that in perspective, that's about how much sunlight Mars receives from our Sun. And we all know what Mars is like. It's frozen solid. So without some kind of powerful warming blanket, Kepler-62f would just be a global snowball. This, of course, leads to the big question. Is it even possible for this world to be warm? What would it take? Well, that's exactly what a team of scientists set out to answer. We can't go there, obviously, so they did the next best thing. They built the planet inside a supercomputer and ran a ton of simulations to see if any scenario could lead to liquid water. They basically tweaked every variable you can imagine. They played with the shape of its orbit. They gave it all kinds of different atmospheres, some thin, some super thick. And, most importantly, they started pumping the atmosphere full of carbon dioxide, a really powerful greenhouse gas, just to see what it would take to warm the planet up.
And here's what they found. The models showed that, yes, Kepler-62f could be habitable, but it needs a very specific recipe. First, it absolutely needs a thick atmosphere, and that atmosphere has to be packed with CO2 to create a strong greenhouse effect. Other things like a high axial tilt could also help create seasons warm enough to melt ice. So it's not impossible, it just has to be the right kind of world.
So, with all the evidence in, where does Kepler-62f actually stand? Is it still a prime suspect in our hunt for life, or is it just another cold case? Let's see how it compares to some of the other big names out there.
Well, it remains one of the absolute best candidates we have. You can see here, a world like Kepler-186f orbits a volatile red dwarf star, which is known for blasting its planets with sterilizing flares. But Kepler-62f gets to enjoy the calm, stable life around its K-type star. That makes it a top-tier contender, but it has one more ace up its sleeve. And this might be the most powerful piece of evidence in its favor. It's something that no computer model can truly capture, but it's arguably the single most important ingredient for life to exist. The Kepler-62 system is 7 billion years old. Let that sink in. Our own Sun and Earth are only about 4.5 billion years old. That means this system has had a 2.5 billion year head start on us. That is just a mind-boggling amount of time for a stable planet to exist, for life to arise, and for it to evolve. So what's the verdict? Kepler-62f is a world of absolutely immense potential. It's got the right size, it's in the right neighborhood, and it has a fantastic parent star. But most importantly, it's had time. So much time. Which leaves us with the ultimate question. If this world really is a global ocean, after 7 billion years, what could be waiting in